Stagnation properties. In dealing with a problem involving flow, many discussion and equation can be simplified by introducing the concept of isentropic stagnation state. And the properties associated with it. The isentropic stagnation state is the state a flowing flow would attain if it underwent a reversible adiabatic deceleration to zero velocity. This state is designated in this chapter with the subscript 0. From the first law for a steady state process, we conclude that for the first law, for example, H plus H0. The actual and isentropic stagnation states for a typical gas or vapor are shown in the HS diagram in this picture. Sometimes it is advantageous to make a distinction between the actual and isentropic stagnation state. The actual stagnation state is the state achieved after an actual deceleration to zero velocity, and there may be irreversibilities associated with the deceleration process. There, the term stagnation property is sometimes reversed for the properties associated with the actual state, and the term total properties stagnation property is sometimes reserved for the properties associated with the actual state. And the total property is used for the isentropic stagnation state. It is evident from this figure that the enthalpy is the same for both actual and isentropic stagnation state. Enthalpy is same for isentropic and actual state. Therefore, for an ideal gas, the actual stagnation temperature is the same as the isentropic stagnation temperature. For ideal gas, T actual, T isentropic. For this reason, the term total pressure, meaning isentropic stagnation pressure, has particular meaning compared to actual stagnation pressure, P actual, P isentropic. The next section is the momentum equation for a control value.